So based on our results of our USA test prep quiz yesterday, it was pretty clear that we need to pretty much review everything in regards to trigonometry just to make sure we're refreshing. So we're going to start here, and for the most part what we're going to do in this class is we're going to stay in the world of right triangle trigonometry. And now a lot of you mentioned in class, you remember the term SOHCAHTOA, things like that, but we struggle with the application right now, remembering everything. So we're just going to do a real basic introduction today. And again, because you've done this before, we're going to go through it a little more quickly than we normally would. So as I said, we're starting with right triangles here, and we're looking at trigonometry, where trigonometry means the study of triangles. And so as we're looking at right triangle trigonometry here, we need to make sure we understand what we're talking about when we talk about SOHCAHTOA, adjacent, opposite, hypotenuse, all those terminologies you need to be very comfortable with. So first thing you need to understand about trigonometry is in order to be able to write a trigonometric ratio, we have to first have an angle we're working with. And so if you notice here, we have A as our angle in all of these. So everything we are doing is in reference to angle A. So as we talk about classifying our sides as opposite, adjacent, and hypotenuse, that information is all relative to angle A. So from angle A, the opposite side, well, is opposite of angle A. You go from your angle across the triangle. The opposite side is the only one that doesn't touch angle A. So that's how you identify opposite. Adjacent, the definition of the word adjacent is next to, and so therefore the two sides that are next to angle A will always, one will be the adjacent, the other will be the hypotenuse, and the hypotenuse is always the longest side, and it is always opposite of the right angle. So if you go to the right angle and go opposite, that's your hypotenuse. The other side that comes together to make angle A would be the adjacent side. So if we would change our angle and go to angle B, well, that would make our opposite and our adjacent flip, because opposite of B would be over here and the adjacent of B would be over here. So the hypotenuse is always a constant. It's always the longest side opposite the right angle. Alright, so our three trigonometric ratios that we're going to focus on in this class are sine, cosine, and tangent. And I've used the abbreviations here that you will see on your calculator. SIN for sine. Sine is actually SINE. But we use these abbreviations pretty much all the time. And all we're talking about when we're talking about trigonometric ratios is fractions. We're just talking about a simple fraction. The sine of angle A is representative to the fraction of the opposite side over the hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse, and tangent is the ratio of the opposite side over the adjacent. It's just your basic writing of fractions. That's all we're going to do today. We're going to start with the very simple parts. Let's look at an example where you have to write ratios on your own given a triangle where you're given two sides of the triangle. In order to find all three ratios, as you'll be asked to do here, the sine, the cosine, and the tangent, we first need to know all three sides. So if you know two sides of a right triangle, we can always use Pythagorean's theorem to find the third side. So you'll see down here, I've done the work for that. I have a leg, and a hypotenuse. So I do leg squared plus leg squared equals hypotenuse squared. Solve that equation and I get the radical 80. Now we've talked about simplifying radicals. We never leave radical 80. We're not going to use decimals. We're going to simplify that down to 4 times the square root of 5. And so our side x is equal to 4 radical 5. So in order to write a trigonometric ratio, all you have to do once you've got the sides is write the fraction based on the angle you're asked about. So when we were asked for the sine of A, all that says is go to angle A, and from that angle write the fraction of the opposite side over the hypotenuse. So that means the sine of A is equal to 8 over 12, and we always reduce our fractions. 8 12 reduces to 2/3. Cosine requires a little bit more of a complex problem because now we're going to get radicals in our fraction. From angle A, the adjacent side was x, so that's our 4 radical 5, and the hypotenuse is 12. So the cosine of A is 4 radical 5 over 12, which you reduce that fraction just like you do any other. 4 12ths reduces to 1/3, and the radical 5 stays there. Finally, from angle A, our tangent is going to be the opposite, 8, over our adjacent x, which is, again, 4 radical 5. So when we reduce 8 over 4 radical 5, I divide those both by 4, giving 2 over radical 5. Except there is our mathematical rule that we never leave a radical in the denominator, so I need to multiply both the top and bottom by radical 5, making 2 radical 5 over 5. This is all you're going to do today. Is you're just going to start with the writing of the fractions. You need to be comfortable with looking at a triangle from the angle, identifying what sides would be the opposite, the adjacent, and the hypotenuse, and then writing the fractions. From there, the rest of the work will become into a lot of basic algebra. So this is the most important day here as we start our trig ratios, is being able to identify the parts of a triangle. Good luck.